I'm Eric Richardson. You can reach me at eric@coho.ca. Opinions are my own and not my employer's. So a good thing about Go is it has a clean modern syntax. It's familiar to other languages, so it's a relatively easy language to pick up if you're familiar with C or Java or Ruby, Python. There's type inference, so it's a much cleaner syntax than like say Java where you're always declaring all your different types all the time. There's smart pointer dereferencing, so if you come from C, none of these arrow things, it's just dot, dot, dot all the way through. It figures it out what you want. And there's a strong sense of minimalism throughout the entire language syntax, that there's not a sense of superfluous words. It's just like, to me, it feels like the bare minimum for a programming language, which makes it easier to learn and creates this sense of simplicity throughout it. Bad thing is it contains the billion-dollar mistake. So I believe it was Tony Hoare, who was working on early type systems, who introduced this in Algol. And in a talk that was in 2009, he admitted it, that, oh, this is my billion-dollar mistake. I kind of knew it was a bad idea at the time, but it was so easy to implement that he couldn't resist back in the 1960s. This has caused numerous crashes in software systems around the world, and Go still has it. Other languages deal with it with like a none type or an option type, so you have to explicitly check. It's funny because Tony Hoare admitted this in like 2009, which came out like just before where Go was publicly announced at 2009 in November 10th. Ugly thing, I mean, it's a Go talk, I guess. But we aren't stuck with this. There are strategies for getting around the ugly parts here. This is from Go's Are Values from Rob Pike's blog there. Notice the no syntax highlighting. I believe he thinks they're childish or he doesn't use it. And when I was looking at his blog, I'm like, oh, I see it now. But for here, one of the strategies he proposes is to declare a closure which wraps over the error, and then you're always going to call over this and only check the error one time instead of going if error does not equal nil, if error does not equal nil. This doesn't always work depending on your use case, but it can be a strategy here. Another example is like this might be a bit more realistic because you aren't always writing to a byte slice. You want to write to a file or whatever. So you can declare a lightweight struct like this with an error type and IO writer. You can initialize. And then you define a function in which if there's an error, you're just going to return and not do anything. Or then you go do your thing and assign the error appropriately. With the declaration here, you pass it a file descriptor that you're going to write to. Note you don't have to declare the error, that this is an example of making the zero value useful, that the error will default to the nil and get assigned there, so you can get a relatively clean declaration. You just keep on calling that function based on that struct you have. And again, you can check the error one time. There's also a similar thing in the scan pattern where you have a scanner that'll iterate over a thing of tokens coming in, and then you'll go for scan.next or rows.next, and then you check your error one time afterwards. Good thing, I feel like this is one of the underappreciated things about Go, is that when you compile it, you get a single binary that you just run. There's no, the runtime's already baked into it. For a large part, like you're probably all right even without a full-blown Docker container. This has saved me multiple times in like some issues where I could just compile a binary and get it to run on a certain server without having to worry about a large runtime associated with it. I just know it's all baked into that single binary, and I don't have to worry about like linking or any dependency on the machine. And the cross compilation that I can go build on my Mac and target a Linux machine is one of what is what I feel an underappreciated strength of Go. One thing I kind of don't like about Go is the lack of enums. We kind of have them that you can go declare a type with an iota, and then you can declare your own string type, and this will still give you type safety if you have functions with a long list of parameters that you aren't going to be able to mix them up accidentally, whereas versus if they're just all ints or all strings, so you do get some of it. We might have to be careful about zero values here. So in this example, we're going to output red even though the C doesn't have a color. Now, depending on your application, that might be a fine default to have, but it might not be. So we might have to declare our like wannabe enum type with an unknown type to fill in for the zero value or skip over it so we don't have to worry about it. This kind of takes away the confidence of just having your code work the first time, even though in this case it's relatively minor because you can go test for this and be like, yeah, it's going to work every time. There's also like, if you have this type, if you're doing a switch statement, you can miss a case. And if you aren't diligent in checking and testing your code, you might miss it. Whereas compared to another language like Rust with a match statement, it's exhaustive and you have to explicitly say, I don't want to deal with any other cases. But yeah. Ugly is the standard library is pretty good, but the rows.scan is one of those things where I'm like, this is kind of annoying when you have to line up your SQL statement with a select and then make sure you get the order exactly right. If you change an order in your select statement, you have to go change it in a rows.scan. Also a side note, it's a pleasure to work with vendors who know what idempotent keys are when you're doing financial transactions. Luckily for the scan thing, there are third-party tools available. So Gorm's one we're using here, but there's also Sequelize and UpperDB. I'm sure there's others, but you don't want to always be using scan all the time. You can look at one of these solutions, bring them into your project to use. Of course, Go routines are one of the most popular talked about things of Go, that it provides a lightweight concurrency way to do concurrency in a lightweight manner, whereas versus a thread in a traditional language where it's actually like a heavy operating system concept, Go gives you a very light user space thread, or green thread as they're sometimes called. Each Go routine has roughly a 4 kilobyte overhead compared to like other full-blown threads, which might be a megabyte. And then they're also very fast to switch between them because you aren't actually doing operating system calls, that the Go runtime's handling the multiplexing with it. It has quite a sophisticated model, and even Rust, Tokyo, their async thing, attributes a lot of their performance gains by looking at Go's implementation of it. So you can read more about it if you want to know what's going on under the hood and why it's great. They also provide channels, which is a great high-level interface for coordinating and syncing between the channels there. Ugly, there's the lack of generics, or at least user-defined ones. There are generic types with maps and slices that you can go define your own type, and then the slice behavior is going to be consistent regardless of the type of slice that it is. But there isn't a way currently in Go to define your own generic. There are some workarounds with, you can use interfaces as long as you're happy implementing your own functions on all the types you want to operate on, or you can use Go template to be able to go get the type, but it's still not quite as satisfactory as having it built in to the language itself. Go also has a very strong tooling platform just right out of the box. It has Go Test, which is gets you most of the way there. You don't have to worry about additional testing frameworks, although there are useful helpers if you so desire. The built-in formatter is great, that there's no more, how are we going to configure JSON prettier?
This is a language standard, it's built, you run it, end of discussion. I think it's like a great benefit for having that as a language standard. And there's also stuff like race condition checkers that it can detect race conditions if you have that on for debugging and testing purposes. Another thing is, it's a growing market, it's a fast-growing language, so there's more and more opportunities to get jobs writing professionally. And I think that trend will continue as it continues to pick up steam and more companies begin to invest in the ecosystem. So it's a good language to learn, ideal because it's still young and growing. In conclusion, it's a strong language.